Now let's talk about Byzantine general problem. Byzantine general problem is a problem in the computer systems in a distributed network where components may fail or may work partially or may not work at all, but it is not easy to determine which node is faulty or which node is being compromised. So in order to understand in more detail, now let's picturize it right now. So now let's understand what is a Byzantine general problem with an example. So let's say there are 4 armies A1, A2, A3 and A4. They all want to attack this kingdom, but they have a constraint. The constraint is until and unless A1, A2, A3 and A4 attacks at the same point of a time, they are not going to win this battle. Since this kingdom is very huge, you have to have that much amount of army in order to win the kingdom. So what can you do in order to achieve this kind of problem? So how they are going to attack is a problem here. So now they have to coordinate with each other. A1 has to coordinate with A2, A1 has to coordinate with A4, A1 has to coordinate with A3, and all A2, A3 and A4 also have to coordinate with each other. So if you take an example of a traditional system, how this works, so let's say A1 will send a message to A4 and he will say we are going to attack on Thursday at 11 am. So A will send this message to A4. Now the message will reach to A4. Let's just assume that the message has reached to A4 successfully, and then A4 will send this message to A3, and then A3 will send message to A2. So everyone now have the same type of data, which is we are going to attack Thursday at 11 o'clock. So this is an ideal situation which ideally does not happen. So what can happen in these cases? Let's say A1 has sent a message to A4, we are going to attack on Friday at 11 am, but kingdom knows this. Somehow they know that A1 and A4, A2 and A3 all are going to attack us and they are going to communicate with each other. So one of the cases can be kingdom will change the message. So instead of the message being transferred to A4 should be Friday. So what kingdom did? Kingdom changed the message. So A1 has sent that we are going to attack on Friday, but kingdom changed the message in between. That's a man in the middle attack. And then what does kingdom did? Kingdom changed it to Saturday. So either A1 have no idea whether the message is being changed. A4 also don't have idea that the message is being changed. So there can be situation which can happen in which A1, A2, A3 and A4 do not have the same type of information. So in the situation in which not all 4 nodes like A1, A2, A3 and A4 do not have the same type of information, they are not going to win this battle. So Byzantine general problem is a kind of a problem in a distributed network in which we have all 4 nodes should have the same kind of information and the same point of a time, and all 4 should trust each other as well. So in that case you can also see if A1 has said we are going to attack on Friday, but A4 is faulty. A4 have transmitted to A3 the attack is on Saturday. So here we can assume that the A4 is faulty. So basically Byzantine general problem states that all the nodes in the network, especially in the distributed network, have to have the same kind of information at same point of a time, and all the nodes should trust each other. So this is a Byzantine general problem. Now this Byzantine general problem is being solved by the blockchain.